You know, back in the day, machining a precision mold component from hardened steel was a multi-week ordeal. Setups, resets, and a whole lot of hoping nothing moved overnight. Today, we're looking at something that would have seemed like science fiction to the guys running those old Bridgeport mills. What you're watching right now is a high-speed 5-axis CNC milling operation on a mold slider, and the material being cut is Tulox 33, a pre-hardened Swedish tool steel known for its outstanding dimensional stability and its ability to hold ultra-tight tolerances right out of the plate, no post-hardening needed. That alone is a game-changer in die and mold manufacturing. The machine doing this extraordinary work is the OPS Ingersoll Eagle V9, a horizontal high-speed machining center engineered specifically for graphite and hardened steel. It features a 60,000 RPM spindle, linear drives on all axes, delivering rapid traverse speeds up to 60 meters per minute, and thermal compensation systems that constantly self-correct for heat-induced drift. The simultaneous 5-axis motion allows the cutter to maintain optimal contact angle throughout the entire toolpath. That's what gives you those mirror-smooth cavity surfaces right off the machine. No grinding, no polishing, just pure precision, start to finish. Close your eyes for just a second and imagine the sound, that deep, rhythmic boom that you feel in your chest before you even hear it in your ears. That's the sound of a drop hammer forge at work, and it's one of the oldest, most satisfying sounds in all of manufacturing. It's a sound that built the railroads. It built the machines that built America. And today, right here at the Bremecker Hammer, the Bremecker Forge, that sound is still very much alive. Bremecker is a traditional German forging operation, and what makes places like this so special is that they've managed to carry an ancient craft all the way into the modern era without losing what made it great. Forging, if you're not familiar, is the process of shaping metal by applying compressive force, typically through a hammer or press, while the metal is at or near forging temperature. And here, that means heating billets of steel in a gas-fired furnace to somewhere between 1,800 and 2,200 degrees Fahrenheit, until the metal glows a brilliant orange-yellow and becomes workable. The drop hammer you see here is a gravity drop hammer, one of the workhorses of the forging world. A heavy ram, anywhere from a few hundred pounds to several tons, is hoisted up by a mechanical lift and then released to fall freely onto the workpiece resting in the lower die. The impact is tremendous. We're talking forces that can exceed several million foot-pounds in a single blow, restructuring the grain of the steel at a molecular level. And that's the real magic of forging, friends. Unlike casting, where you pour liquid metal into a mold and let it solidify, forging actually refines the grain structure of the steel. It closes up internal voids, aligns the crystalline structure along the stress lines of the part, and produces a component that is genuinely stronger, tougher, and more fatigue-resistant than anything you could machine from a solid bar or pull from a casting. Watch how the smith rotates the billet between blows. That's not random. Every movement is calculated, repositioning the workpiece so that each hammer strike shapes a different face, gradually bringing the rough billet closer to the final form with remarkable control. This is skilled craftsmanship working in harmony with raw industrial power, and there is nothing else quite like it in the world. Now we're shifting gears completely, from hammers and steel to something almost impossibly beautiful. This is hot glass blowing at Holdman Studios, one of America's most celebrated art glass workshops. And if you've never watched a master glass blower at work, you are in for a genuine treat today. The furnace you see burning in the background holds molten glass at around 2,100 degrees Fahrenheit, hot enough to glow a deep, molten amber orange. The artist gathers a molten gather of glass onto the end of a blowpipe, a long, hollow steel rod, by rotating it slowly inside the furnace to collect an even, symmetrical blob of liquid glass. From that moment on, it's a race against time and temperature. Glass has what's called a working range, a window between about 1500 and 2000 degrees where it's soft enough to shape but not so fluid that it loses form. The artist blows a small bubble of air into the gather, then shapes it using wooden blocks soaked in water, steel jacks, and sheer hand pressure, all while keeping that pipe spinning constantly to prevent gravity from pulling the molten glass out of round. What Holdman Studios is especially known for is their extraordinary use of color, layering rods of colored glass called cane into the surface of the gather before the final shaping, creating internal patterns of breathtaking depth and complexity. The result is finished artwork that looks like it was painted from the inside. This is manufacturing elevated to pure art. Now this right here is one of the most impressive pieces of construction equipment you will ever see in your life. And I want you to notice something important. There is no scaffolding under that bridge. No temporary supports touching the ground below. None. What you're watching is a self-launching beam launcher, known in the industry as a lanzavigas, lifting massive precast concrete bridge girders and placing them precisely between bridge piers, all without ever needing a thing below the deck line to hold itself up. Let's talk about how this works, because the engineering is genuinely breathtaking. A lanzavigas is essentially a mobile overhead gantry crane that rides on the tops of the bridge piers themselves. It straddles 2 or 3 spans at once, using its front and rear support legs, called legs or trusses, to transfer its own weight and the weight of the beam load directly down onto the completed pier caps. The main girder of the machine can extend forward, launching itself ahead to the next pier, completely self-propelled and self-supporting. The precast concrete girders being placed here, these are not small objects. A typical highway bridge girder can be anywhere from 60 to 180 feet long and weigh 60 to 120 tons. And the lanzavigas picks them up from a delivery vehicle or trailer at the back of the completed bridge deck, carries them forward along its overhead beam, and then lowers them with millimeter-level precision into their final position between the piers, all without any ground-level falsework that would otherwise block traffic, waterways, or ravines below. The advantages over traditional scaffolding construction are enormous. In river crossings, canyon bridges, or urban overpasses where shutting down traffic below would be impractical or even impossible, a self-launching beam launcher is often the only viable option. It dramatically reduces construction time, slashes the risk of working at height on temporary structures, and produces a cleaner, safer work site. The speed is remarkable. In ideal conditions, a skilled crew can place multiple girders in a single shift. One look at this machine in motion, and it's easy to understand why it has become the standard tool for modern bridge construction worldwide. If you've ever operated a valve on a pipeline, a gate on a dam, or a damper in an HVAC system, there's a very good chance you were turning a worm gear actuator, and there's a good chance it was made by UMA. UMA Drives GmbH is one of Germany's premier manufacturers of industrial gearboxes, and what you're watching here is the precision production of worm gear sets, one of the most elegant and reliable mechanical arrangements ever devised. A worm gear set consists of 2 main components: the worm, a helical screw, and the worm wheel, a gear with specially curved teeth designed to mesh smoothly with the worm's thread. The defining characteristic of a worm drive is its dramatic gear ratio in a compact package. A single-stage worm gear can deliver ratios from 5:1 all the way up to 100:1 or more, meaning one turn of the input shaft produces only a fraction of a turn on the output, but with a massive multiplication of torque. At UMA, each worm is precision ground from case-hardened steel using dedicated worm grinding machines with thread profile accuracy measured in microns. The worm wheels are typically cast from high-tin bronze, chosen for its excellent lubricity and wear resistance against the hardened steel worm. After hobbing the wheel teeth on a gear hobbing machine, both components undergo rigorous quality inspection, including CMM measurement and contact pattern verification under load. The result is a gearbox built to run for decades with minimal maintenance, quiet, powerful, and utterly dependable.